Today's classwork was numbers 7 and 8 from our workshop. Let's start with number 7, marriages in the U.S. Data shows that fewer U.S. adults are getting married. The data can be modeled by the following system of linear equations. So right away, I'm like, score! It gave me my system. So don't be trying to just write something else. We have it right here, which is nice. Not only that, but it defined my variables for me as well. X is the number of years after 1970, so we have this idea of a 0 year, and Y is the percentage of adults. So here in our top equation, negative 3x plus 10y equals 160, this little balloon tells me that this represents the percentage of never married American adults starting with 1970. So people who never got married are represented by this equation. And then x plus 2y equals 142 is the percentage of married American adults, so the percentage of people who are married, starting with a 0 year of 1970. Part A says, use these models to determine the year, rounded to the nearest year, when the percentage of never married adults will be the same as the percentage of married adults. And then for that year, approximately what percentage of Americans will belong to each group? When will they be the same? Solving this system will find me where these two lines intersect. If I were to graph them, where they intersect is that answer to this question. So to find that point, we will solve the system. Like I said, we already have our system, so we're going to bring it down. Negative 3x plus 10y equals 160. And x plus 2y equals 142. This is a standard form system. It's given to me like that, standard form. Or if you like, instead of writing standard form, you could write ax plus by equals c system. The consensus in class is that elimination is the way to go. So let's decide if we want x's or y's to cancel. To have inverses, this is already a negative 3x. I very easily could make this a positive 3x. If I wanted my y's to cancel, this is a positive 10. I could also just modify this equation by multiplying by a negative 5 to get this to cancel. I see that I already have this negative positive relationship with the x values. So I choose to have x's cancel. I will create inverses for x by multiplying this second equation by 3. Let's write our new system. So this is negative 3x plus 10y equals 160. We didn't touch the top equation. The bottom equation becomes 3 times x is 3x, 3 times 2y is 6y equals, and 3 times 142. If your calculator's not out yet and you hadn't done this one, go get your calculator. 3 times 142. So press pause, go get your calculator, come back. 3 times 142, 426. If we've chosen right, 426. If we've chosen a correct approach with what we multiplied by, something should cancel. It does. Negative 3x, let's put a plus sign out here, adding these together. Negative 3x plus 3x is gone. 10y plus 6y is 16y. And 160 plus 426 is 586. Divide both sides by 16. 586 divided by 16. I get y equals, I got 36.625. So here's my answer. What does this answer mean? Y is defined as the percent of adults. And we need to read for information because I'm told round to the nearest percent. So if we're going to round to the nearest percent, what is the right answer? What's the real world? Excuse me. We have the right answer, but what is the real world answer if we're told to round to the nearest percent? Rounding this to the nearest percent would be 37%. I have y. I need to go solve for x. So I choose to substitute into the second equation. X plus 2y equals 142. This becomes x plus 2 times 37 equals 142. 37 times 2 is 74, so this becomes x plus 74 equals 142. Subtracting 74 from both sides, x equals 142 minus 74 is 68. So here's my math answer. We did have these directions to round to the nearest year, but we did not end up with a decimal year, so that is not something we need to use. However, what does 68 mean? We found a value for x. We come back up here. X is the number of years after 1970. So 68 years after 1970 would be 1970 plus 68 equals 1970 plus 68 is the year 2038. What does all of this mean? Determining the year. So for what it means, look what I just did. Come right back up to the question. Determine the year when the percentage of never married adults will be the same as the percentage of married adults. So in the year, in 2038, the percentage of never married adults and married adults both equal 37%. That's when the percentage is the same. How is your approximate solution from part A shown by the following graph? So if you notice, look at the equations you're given. Negative 3x plus 10y equals 160. X plus 2y equals 142. Negative 3x plus 10y equals 160. X plus 2y equals 142. So this question actually took your two equations and graphed them. What was our solution from part B? Solution. Our approximate solution from question B, x comma y, is 68 comma 36 point, oh, no, we rounded, 68 comma 37. I should add in approximate, because rounding was involved. How does this compare with the graph? Where's the solution? Where's the point of intersection on this graph? Well, these two lines intersect right here is that approximately 68, comma, 37. Approximate solution from B matches the point of intersection on the graph. Number 8. Bushnell Theater. Tickets for the Bushnell Theater are $5 for the balcony and $10 for the orchestra. If 500 tickets were sold and the total receipts were $3,500, how many tickets were sold for the balcony and how many tickets were sold for the orchestra? As always, let's underline our question first. How many tickets were sold for the balcony and how many tickets were sold for the orchestra? This is a how many of each number question, so right away I know this is an AX plus BY equals C system. From the question we can get our variables. How many of something is talking about the number of what? How many tickets were sold? Let's see, how many tickets were sold for the balcony? So X will say number of balcony tickets. We'll have Y be the number of, what's the other kind of ticket? Orchestra? Now that we have our variables defined, let's go get some information. We need to mentally group what goes together. So when I read this again, I clearly see information about cost. So I'm going to write cost, and I'm going to make that yellow. Highlighters help. $5 for the balcony and $10 for the orchestra. So this is money, money. Do I have total money? Total receipts, $3,500. How would we write that as an equation, a standard form equation? Well, balcony is X, $5 for the balcony, 5X plus $10 for the orchestra, 10Y equals total money, $3,500. Once we've used these values, we can't use them again. So consider them off limits for our next equation. What other piece of information do we have? We're told 500 tickets are sold. 500 tickets is the total number of both tickets put together. So we have an equation that's about the number sold. The number of balcony tickets represented by X, because that's how X is defined, X plus the number of orchestra tickets, Y, equals 500 tickets. Number plus number equals total number. We now have our system. It is a standard form system. We will use elimination. Make a decision if you want X's or Y's to cancel. I say I'm going to choose X. How would we get X's to cancel? This is a positive 5X. The opposite of a positive 5X is a negative 5. So I'm going to multiply the entire second equation by negative 5. Side note, getting Y's to eliminate would be just as valid of a choice because I easily could have just multiplied this by negative 10 instead. And then I'd have a positive 10, negative 10. So if you want to do that, feel free. If you did do that, that's great. We should still end up with the same answer. Writing our new system, we did not touch the top equation. That stays. 5X plus 10Y equals 3,500. The bottom equation becomes negative 5X minus 5y equals negative 5 times 500. Negative 5 times 500 is what? I got negative 2,500. We're now ready to add these together, see what eliminates. My 5x minus 5x is 0. 10y minus 5y, 5y equals 3,500 minus 2,500 is 1,000. We'll divide both sides by 5, and we get what? 1,000 divided by 5, 200. 200, what does 200 represent? Y is the number of orchestra tickets. So 200 orchestra tickets We know the number of orchestra tickets. How do we go find the balcony tickets? We are going to substitute into one of our original equations. This one to me looks a little more user-friendly. So x plus y equals 500 becomes x plus 200 equals 500. We'll simply subtract 200 from both sides. And x equals 300. Again, 300 what? I come back here, x is number of balcony tickets, so I know that this is 300 balcony tickets. The question did not ask for the answer to be written as a complete sentence. So as long as you have nice, clear labels on what your answers mean, we're good. A sentence would not be that much of a stretch. We would simply say the Bushnell Theater sold 200 orchestra tickets and 300 balcony tickets, and we're done. Number 9, the Roma Bicycle Company is planning to make a low-price, ultralight bicycle. There are 2 different plans being considered for building this bicycle. As soon as I hear this, 2 different plans, I know I will be keeping an eye out for 2 plans. The first plan includes a cost of $125,000 to design and build a prototype bicycle. The materials and labor costs for each bike made under the first plan will be $225. The second plan includes a cost of $100,000 to design and build the prototype. The materials and labor costs for each bike made under the second plan will be $275. You recently got a job at Roma Bicycle Company as a financial analyst. Congratulations to you. You have been asked to analyze the costs for each proposed bicycle prototype. Determine which plan Roma should follow. We are comparing here, one to another. So I know that this will be a y equals mx plus b system. You're determining when is one better than the other. Let's first look for our variables, x equals, y equals. I know that this is all about bikes. So it's $125,000 to design and build a prototype bike. $225 is the materials per bike. Ooh, look at that, each bike. So I know x will be, I don't want to cover it up too much. Third time's the charm. Not close enough. Okay. X is number of bikes, not per bike or each bike, number of bikes. Once you know how many bikes are being made, we can figure out total cost of the plan. we are comparing two plans. Do they have names? I think it just says first plan and second plan. So first plan, second plan. Getting these labels down really will help us to organize our information. This is quite a bit of reading, which is not a bad thing. It just means we have an awesome amount of information. But we want to have a strategy on how to approach this much information. So knowing what we're comparing and actually writing those names down can help. Because I'm going to make first plan one color. Second plan will be another color. Let's go look for information on the first plan. First plan includes a cost of $125,000 to design and build a prototype. Materials and labor made under the first, okay, this is about the first plan too. Made under the first plan, $225,000. After that, it starts talking about the second plan. So let's just use what we highlighted in yellow to write our first plan equation. Y equals. We need an initial value and a rate is what we're looking for. What do we got? Well, it tells me $125,000 to build a prototype. When companies are inventing things, they build a prototype, just one. So it's going to be a single prototype, a one-time cost to them to build the prototype, plus the materials and labor for each bike is $225. So $225 per bike. We've got our first plan. Let's go look for the second plan. I'm going to make that blue. Second plan includes $100,000 to design and build the prototype. And then materials and labor under the second plan, $275. Please press pause, spacebar for pause, and write the second plan equation on your own. I get Y equals $100,000 for the prototype plus $275 per bike for labor and materials. So notice how nicely just using our colors and labeling what each equation will be about really helps to break down what we were given here. Highlighters rock, okay? Use color. So we need to figure out which plan Roma should follow, this business. But before we can give them advice, we have to figure out when will it not matter which plan they choose. So to do that, we are going to set these equal. $125,000 plus 225x equals $100,000 plus 275x. Go ahead and pause the video, please, if you have not done this one yet, and solve this on your own. Get x's to one side, numbers to the other. I choose to subtract 125,000 from both sides. Minus 125,000, minus 120,000. Okay, line all the way across. Keep it nice and neat. 225x equals, let's do 100,000 minus 125,000. 125,000. I get negative 25,000. And be careful, make sure we don't get happy with the zeros and keep adding too many, okay? Count carefully when you do this. When you're entering things in, just be careful. And then I bring down the positive 275x. Next, we will subtract 275x from both sides. $225 minus 275 gets us a negative 50x equals negative 25,000. Now at first, this negative is a red flag. We can't have negative bikes, negative money. But I see that I'm about to have a negative divided by a negative, so I know I'm okay. If this did not happen, check your work, because we can't have negative bikes or money. So I know, like I said, negative divided by negative is a positive, so I'm just going to use the calculator to do 25,000 divided by 50, and I get 500. Question of the day, 500 what? Go back to your variables. X represents the bikes. So X equals 500 bikes. What does this mean? It is when these plans are equal, when the first plan equals the second plan. So if Roma, let's use the company's name, if Roma plans on building or building 500 bikes, they can choose either company. It's when the cost would be equal for both. So that's cool, because let's say they only want to build 500 bikes, then they could financially be safe to choose either one. Maybe they have a preference, which is great, because then they can just choose the one that sounds better, looks better, better reviews. What if they don't want to build 500 bikes? This is where helping to give them advice comes into play. Let's say they don't want to build 500 bikes, they want to build 1,000 bikes. No, let's not work with 1,000. 1,000 is big. We just need to work with something bigger than 500 is what I'm thinking. But if you're like, yeah, I want to work with 1,000, go ahead. But let's say 600 bikes. 600 is more than 500. So the result will be the same. Advice. Assume 600 bikes. Let's see what we get. First plan. The first plan will be y equals 125,000 plus 225 times 600. Where we saw x, we will substitute in 600. That's 125,000 plus 225 times 600 equals 135,000. Adding those values together, I got 260,000. Second plan, we're going to do the same math, just using the other equation. The second plan equation is right here. Y equals 100,000 plus 275 times 600. That is 100,000 plus 165,000. So what we're doing right now is purely an exercise with the calculator, plugging in 600 and seeing what we get. So that is 265,000. So building 600 bikes, which plan is better? The first plan will cost them $5,000 less. Remember, double box it, highlight it, do whatever you need to do to indicate that this is the better choice. It's cheaper. So if the first plan is cheaper for 600 bikes, it will be cheaper for any number bigger than 500. So our advice will be if Roma wants to build more than 500 bikes, choose the first plan. Now, in terms of giving advice, maybe you wanted to say, well, they're a really small company. I think they're only going to want to build 100 bikes. If more than 500 bikes, they should choose the first plan. That automatically means that less than 500 bikes, they're going to choose the second plan. So maybe you said assume 100 bikes. If you assumed 100 bikes or a value less than 500, the second plan would come out to be cheaper, and that's just as valid advice. As long as you have math to back it up and a sentence telling me the conclusion of your results, we're in great shape. This finishes the video for 7 and 8.